Hello and welcome to our IoT-lab for SME. Today we are going to talk about pilot cases and connectivity. Hey, let's start with David.
Yeah, let's introduce ourselves. So my name is David and I work as a research engineer in this project called IoT-lab for SME. I work together with Neda. Maybe you can present yourself.
I am Neda Maliki, a postdoctoral researcher, and I'm working in the same project called IoT for SME. Here we are a group of 12 people working in this project, and the project manager is Fredrik Algren.
And the project is also financed by the European Regional Development Fund via the Swedish Agency for Economic and Regional Growth. We also have two other financiers, which are Region Kalmar and Region Kronoberg. Yes.
So we bring IoT to your company. Yes. How? We have three types of activities: workshops, open lab days, and pilot cases. In workshops, you can come and have hands-on and
activities.
Yes, on the with the sensors, with the hardwares, and how to connect them and send the data to the cloud, and how to visualize your data.
Yeah, and then we have open lab days.
Yeah.
And then open lab days are days where we usually invite companies that come and talk about IoT, how they use IoT, how they tackle problems using IoT during lunchtime. And then after lunch from 1 to 5 usually we have an open lab, just as the name suggests, so where companies can come and discuss ideas, maybe
they want to test the ideas.
Test ideas. We also sometimes demo prototypes. Yeah. So that's how we spent our open lab days.
Yeah. What is the benefit for you?
So as a company, you might have an idea, or you might not have an idea, but have heard of IoT. So participating in one of those activities might help you identify potential IoT application in the context of your business.
Yeah, and you can be inspired by having a practical experience. Or you can realize your ideas through evaluation, experiments, and prototypes. What else?
Yeah, so that's basically what we help companies with. Sometimes companies come to us with an idea, and then we do some evaluation of that idea, see if there exists, for example, a sensor that measures that physical value that the company is interested in, and then we either suggest that the company do some take a look into that sensor, or we perhaps might already have that sensor, so then we can show the company, okay, this is how the sensor works, this is how you fetch data from the sensor, and this is how you could send the data.
And the most important is that you can integrate IoT in your business model.
Yes. So not only do we show you how to get started with IoT, we do also help you look at IoT from a business perspective and see how you could, as a company, make a product of the IoT solution, basically.
Let's start with the first pilot case.
Yes.
It's called Aquatech.
Yes. So Aquatech is a company that sells nozzle to other companies that clean the sewage pipes, underground pipes, and Aquatech is mostly interested in measuring the pressure at the nozzle, and then also the position of the nozzle. So as we can see in this diagram, we have the vehicle that is feeding this hose with the nozzle attached, and then Aquatech wants to provide some information to the operator of this vehicle so that he or she knows exactly where the nozzle is, and also the water pressure of the
David,
nozzle.
why they need measure pressure?
So
Mhm.
the pressure is interesting because sometimes you need to adjust depending on how steep the pipe is.
Yeah.
Sometimes you need different pressures to
Yeah.
make the hose and the nozzle
Yeah.
advance.
Okay, push it.
Yeah, exactly. So that
Yes.
needs to be adjusted sometimes. So it's
Mhm.
for that reason very practical to know the
Nice.
pressure at the nozzle.
Yeah.
The position of the nozzle is interesting because sometimes you have situations where the operator is feeding the
Mhm.
hose
Yeah.
while the nozzle is actually stuck at a place where it's clogged.
Yeah,
So,
like
but
in the photo, you can see maybe it's blocked by the roots of the tree.
exactly.
Then we wanna to prevent.
Yeah, we want to know if it's stuck or
Yeah.
if it's still advancing,
Yeah.
basically.
So what?
Yeah, this is what we.
Harvest.
Yeah,
Yeah.
this is what we proposed. We weren't sure about what communication technology to use,
Yeah.
so we decided to do an experiment
Mhm.
to test different communication technologies, basically. So in
Mhm.
this case, as you can see, we tried LoRa both with 433 megahertz
Yeah.
and 868. Megahertz, and we also tried NB-IoT. So we had, as you can see in the picture to the right hand side, you have
Mhm.
two boxes.
Yeah.
The lower box contains two devices. One of them both using LoRa. So one is using 433, and then the other one is using 868 megahertz. And in the box just above it, we have a device that is using NB-IoT. And this
Mhm.
is these devices are constructed in pairs. So you
Mhm.
have those devices that are going down into the pipe
Yeah.
are senders,
Mhm.
and then above ground we also had three devices that acted as receivers.
Oh,
So we can in real time know that, okay, we're getting data from this device,
Yeah.
from, for example, the LoRa 433 megahertz, but we're not getting any response from the other ones.
That's good.
So that's one pilot case.
Let's go to second pilot case. It's Svenska Våg.
Yes, and Svenska Våg, they are specialists in scales, so they're very small scales up to very huge
Yeah.
scales, weighing up to, for weighing up to
Mhm.
objects up to maybe 70 tons.
Wow.
Yeah, so it's
Big scale.
yeah.
Yeah. And in the photo, you can see.
We can see different types
Yeah.
of scales, and they also want a solution
Mhm.
where they can read weight values remotely.
Yeah.
And the solution should also be integrated into the existing system. So we shouldn't add anything new that runs in parallel to what exists today, system-wise.
Mhm. So
Yes, and for this
this technology we used.
Yes, we propose to use a bridge between RS485, which is a Modbus protocol, specifically here RTU, so we have the thing wired to the device that calculates the weight, and then when we read that value, we transfer it to the thing's network. So we're using LoRaWAN in this case, and here in the
why we use LTE bridge? LoRaWAN bridge and LTE bridge. Why you propose two solutions?
Yeah, so we propose two solutions for the reason that sometimes
Mhm.
you do have LoRaWAN coverage, and
Uh-huh.
sometimes you don't. So
In the case that we don't have LoRaWAN coverage, then we will switch to
to LTE.
LTE.
And make use of the existing infrastructure instead of
Yeah.
building building infrastructure for LoRaWAN. So we can take advantage of it when
Mhm.
it exists, when it's there, and
Yeah.
then when it's not, then we also have
Yeah.
another solution. Which
I think because LTE is costly.
yeah. So if you use LTE,
Cost-wise.
usually
Mhm.
you need SIM cards,
Yeah.
and those usually cost. While LoRaWAN, if you have your own infrastructure, then
Yes.
you're
Yeah.
using this. It's a
This.
free band.
Mhm.
It's
Nice.
an ISM band, so it's free.
And this third pilot case is QTF.
Yes. So QTF, they purify or they clean the system liquid,
Yeah.
and more specifically, they degas this liquid. So what they do is that they have a system liquid, and then they want to extract all
Yeah.
gases
Mm-hmm.
from this liquid. So for them, it's interesting to know the CO2 levels. Since they also filter this liquid, they
Then
want
water pressure.
they want to
Yeah.
know the water pressure going into the filter tube and going out. This way they know how the filter is doing, if the filter needs to be changed or not.
Okay.
They also want to monitor deviations in magnetic field. So they have a circulation pump
Yep.
that is on, and in cases where the circulation pump is not working, they want to turn off the whole system.
Okay.
Shut down the whole system, as since not shutting it down might damage
Yeah.
the other parts of the system.
Yes.
And
Yeah, you bring the purpose technology for them.
yes.
Yeah.
So these sites are not always above ground. Sometimes you have them in basements, and we know that sometimes in basements we don't have very good coverage.
Yeah.
So
we need.
yeah. So in this case,
LTE.
we have proposed using LTE,
Yeah.
more specifically NB-IoT, which is a simplified version of a simplified protocol of LTE and 4G that we use today. So we have an ESP32 with an LTE modem, and then we also have some CO2 sensor that is sampling or measuring the CO2 level and transmitting those values using NB-IoT. Same thing with water pressure. So those water pressure sensors are also the measurements are also sent using NB-IoT. And then we have the Hall effect or the deviation magnetic field. Those values are sent directly into the PLC, the nearby PLC, using TCP/IP. This is to, as we mentioned earlier, as soon as we see that the circulation pump is not operational, we want to shut down the rest of the system.
Okay.
So this way we do have coverage, even though if it's in a basement. Now, of course, it varies.
Yeah.
Not all basements are not alike. So, but yeah.
Yeah. Nice. Okay. The next pilot case is Beelab. In this pilot case, we wanna monitor the following criteria. I mean, properties
Yes.
in a beehive, like temperature inside and outside the hive, humidity, air pressure, air quality, frame rate, and CO2. Okay, why we wanna measure it? Actually, beehive are very important. I mean, bees are very important, and beekeepers wants to monitor the bee population, and they want to know the level of the honey production. So they try to measure the properties, and then in this pilot case, we are using ESP32 with an LTE modem, and we want to have a one circuit for all. And of course, we are caring about battery.
Yeah. So these will be placed far out in the forests, and we don't know where these beehives are gonna be placed.
David, why we don't use in this case LoRa?
Yeah, so that's also again the same problem. Not we cannot guarantee that
Coverage.
there will be LoRaWAN coverage, since it's the infrastructure is not always there, and this is why we in those two cases that we're falling back to using LTE, because there we do have an existing infrastructure and that we also can use. So yeah, that's in this case why we're using LTE over LoRaWAN, even if it's LTE usually is more costly in terms of power consumption.
Exactly.
So are we using LoRaWAN and LTE?
Yeah, it's a trade-off.
Yeah. So it's a trade-off, but in this case we're also doing deep sleep, no?
Yeah. Oh, for power saving, of course, we are using deep sleep.
So how often are we sending data?
Every 20 minutes we are sending data.
Yeah, that's in the summers. We do send.
but it varies if we are in the winter or in the summer. So it's the scheduling is different.
Yeah.
Yeah, and
but yeah, for Beelab, that's basically it. We have two different schedules for summer and winter. In winter, maybe we don't send data that often.
Yeah, because bees are not much active. So they are active from I think from February to end of the September. They are much active. So we want to know their situation in summer period of time, and then shall we talk about the traditional setup that already beekeepers?
Yeah, so in this case, the Beelab, the company Beelab Technology Sweden AB do actually have connected beehives already today.
Yeah.
But they're using Raspberry Pi.
Yeah, before they use Raspberry Pi.
Yes.
And also now we are using LTE, but
so
how are they doing with
how are they doing with the internet connection? How are they powering the
actually they powered through PoE.
Yeah.
And
so
then
power of Ethernet,
and then it's not power efficient, so they will change or switch to this new setup that we are proposing them.
Also, if you want to place it like far into
in terms of scalability, or
no, I mean if you want to put it far into the forest, and then you have this restriction of having to have an internet cable to actually power it. So making it wireless is ideal.
Power efficient.
Yeah.
Nice.
Yes.
And the next pilot case is about it's called Flowbeak, and we are talking about Kalmar Demme. That is a human constructed dam.
Yeah, and that's also a place where the Institution of Biology here at Linnaeus University very interested in the microclimate of this area. And
what they are measuring in this demme?
So they want to know the temperature, the CO2 levels, PM particle levels, conductivity in water, humidity, wind speed, and also water level.
Yeah. And the direction of the wind.
Is of interest. And what did we do here?
Yeah, we are using LoRaWAN protocol.
Yeah, the LoRaWAN protocol.
And then we are using Helium network instead of the TTN because of its high coverage. Yes. And then, as you can see in the photo, we installed some sensors, and then we are measuring the water level.
Yeah. So in the picture to the left is the water level sensor.
Yes, and the right is the
weather station.
Station. Yeah.
So this was, and those all sensors that we used in this pilot case has been commercial sensors. So sensors, LoRaWAN enabled sensors basically. So you buy those sensors, you onboard them to a certain network, and then you make use of them, basically.
Lots of data we have now.
Yeah, so here I think it's around, we have around 20 or 21 sensors.
Uh-huh.
Yeah.
21 sensors.
Yeah,
are
placed. We can
placed.
see it actually in this image. So
Yeah,
the
there's a
text
map.
in red. Yeah, this is a mapping of all the sensors. So we
Yeah.
can see wind 2, wind 3. It's up to 3. So we have 3 wind stations or weather stations, 3 wind sensors, and then we also have 10 water level sensors.
Okay, the next pilot case is Honestbox. What is Honestbox?
So Honestbox
store?
is so they provide services to companies that want to start unmanned stores or shops. So basically a shop where you can go to at any point in time and then purchase whatever you like and then leave the place without anyone serving you. So you don't have any cashiers. You do everything by your own, basically.
So they want to monitor the area.
Not monitor the area, but they want to have a system where they can control these control boxes. So they have locks. As soon as I identify myself, that identification, if it's successful, that should go as a signal to the server, which will authenticate the customer, and then which will send a feedback to the control box, which then unlocks the either entry door or cabinet. And they also want dual connectivity. So at some stores, for example, if you do in tennis halls, you have generally very poor coverage. So
indoor.
Sometimes LTE is not an option, and you also have places where sometimes Wi-Fi is not an option. So they want this dual connectivity to not have to choose. When they send out a device or a control box, it should be compatible with both and try.
They can switch whenever they need it.
Jump between the.
So the proposed.
Yes. So again here, we were proposing to use an ESP32 with an LTE modem because we do know that ESP32 actually have Wi-Fi functionality, but combined with an LTE modem, then we do have Wi-Fi and also LTE. And then that way we could start creating some form of resilient connection where it tries to use Wi-Fi, and if Wi-Fi is not available,
then
it jumps to LTE and tries LTE. And we also try to be able to update those devices over the air. So for example, if we want to patch a new firmware onto the device, or if we want to add extra functionality, we don't have to get the device back and physically have access
can do
to
it remotely. And is it secure?
So depending on what platform you use, often that data is encrypted and usually over, for example, over SSL. Yes.
Nice. Okay, the next pilot case is Stens Chark, and David and me had a travel there. So you can see in the picture there is a cold storage room. You can see the 2 white doors there, and they wanted to measure, monitor temperature and humidity. So we proposed them you can use temperature and humidity sensor and install them and use the LoRaWAN indoor gateway,
which we can see here.
You can see
at the bottom left.
At the bottom left, yes.
And on the top right, we actually do see Fredrik holding this one of the temperature and humidity sensors.
And then the right bottom, you can see how they are visualized.
So we have some historical data and also some not instantaneous data, but basically the last
every day they should go and
take notes
by hand. So we automate for them. And every week they will report to the authority. Easily. PM and Venner. What is it?
So PM Venner is a hotel and restaurant
Yeah.
chain. I think they have around 4 kitchens and also a
Okay.
hotel.
Yeah.
Um,
So they wanna monitor food waste.
yes.
Why measuring food waste is important?
So this is one of the things that PM and Venner actually puts a lot
Mhm.
of effort into
Mhm.
minimizing the food waste
Yeah.
for obviously sustainability reasons.
Yeah.
So today what they do is to document the food waste. They have the actual food waste, and then they use the scale that we can see here on the top right picture.
They go and write down
Right. So
manually how much
they
food
weigh
is wasted.
yeah so they weigh the container, and then
Mhm.
they also by hand write why was this waste.
The reasons of
Yeah.
maybe.
Basically a reason as to why you're doing this why are you
Yeah.
weighing.
Yeah. So what we proposed is that they can read scale values through RS-232 interface and send the data over the Bluetooth to the user interface and combine the value with the reason. So you can see in the picture, design a website for them,
Yes.
and then in
In this
photo
graphical user interface,
you can see that, for example, this kitchen name, that is kitchen 2, and scale number is scale number 3. This type of material is wasted with this amount of weight, and the reason can be is based on the reason can be one of these.
Yes.
And the staff will use this.
Yeah, so basically this is we're not changing the way that they document in.
Okay.
It's we're trying to
Use it
to gamify the process to make it more fun to do something such as documenting things.
And why Bluetooth? I just want to talk why they choose.
So we use Bluetooth to basically for modularity, because today they might have one scale, but in a week or two or next year they might buy 2 or more scales, and then we want a modular system. So it doesn't matter how many scales you have. Basically, when you use the user interface, you can just stand close by to the scale that you're going to be using, and then select that scale and do your documentation. Without so
nice.
Just as simple as possible.
Okay.
So that's why we're using Bluetooth in this case. Yes, that
and
was
our pilot cases summary. Thank you for joining us to this online open lab. We hope you enjoyed it, and we are looking forward to you. If you have any question, don't please hesitate to contact us.
And you have your contact information here, and you also can on Google search for IoT-lab SMF LNU, and then you'll most likely land on our project page. And you can read a summary of all the pilot cases and our blog in the project page where we do sometimes, or we try to once a week update.
And if you are interested in the pilot cases that we have done, you can check out our recently published paper. And get more detailed information about it.
Yes.